Leslie Brandt is with us, and she will talk about climate change and forest vulnerability. Leslie Brandt is the Regional Climate Change Coordinator for the Eastern Region of the U.S. Forest Service and a climate change specialist with the Northern Institute of Applied Climate Science and the U.S. Forest Service, where she works on climate change adaptation and outreach for natural resource managers. Her areas of focus include urban forestry, central hardwoods forest, and recreation. So I will turn it over to Leslie to give her presentation.
Thanks, Brian. Let me just get my screen pulled up here. Trying to get there we go. Thanks. Thanks for having me. As Brian mentioned, I am a climate change specialist with the U.S. Forest Service. I'm also part of a group called the Northern Institute of Applied Climate Science. And we are chartered by the Forest Service and include partners at universities, including University of Minnesota, Michigan Tech, and University of Vermont. And then we have several other organizations that are part of our group, including American Forests, National Council for Air and Stream Improvement, and the Great Lakes Indian Fish and Wildlife Commission. And we work together to integrate considerations of climate change into natural resource management, working across the Midwest and Northeast. We also run the Northern Forest Climate Hub as part of the USDA Climate Hubs. And the goal for the Climate Hubs is to connect people to existing climate change resources, provide technical assistance and support, and to link regional partners and coordinate collaborations. So we do a lot of work with the forestry sector across our region, as well as working somewhat on the outside of our region as well. And one of the main programs that we have been running over a decade now is called the Climate Change Response Framework. And this operates at an eco-regional scale where we develop vulnerability assessments and adaptation projects across these large ecoregions, including the Central Hardwoods region in the Missouri Ozarks, and that's what I'll be talking about today. The Climate Change Response Framework includes a 4-step approach where we develop partnerships with multiple organizations, develop vulnerability assessments looking at the impacts of climate change on our forests and other natural resources. And then we have developed a suite of tools to integrate climate change considerations into forest management that we call forest adaptation resources, and then have developed examples of adaptation across our region. So I'm first going to talk about the vulnerability assessment that we developed, and then later in my presentation, I will be talking about the adaptation work that we're doing. The Climate Change Vulnerability Assessment was published in 2014 and can be downloaded for free from the Forest Service website. You can also request a paper copy from me if you would like. I have plenty of those copies. And so it covers this region shown in yellow, which includes the Ozarks of the state of Missouri. The assessment includes trends in past climate, so looking at changes over a 110-year period from 1901 to 2011 and looking at significant changes. If you're looking just at mean annual temperature for this region, we haven't really seen a significant increase or decrease, and a lot of that has to do with the fact that there were some really hot years during the Dust Bowl era as well as in the 1950s. But then more recently, temperatures have been on an upward trend. Where we have seen some consistent change, though, is in our summer temperatures, where daily highs have gone down and then summer lows have increased. So there's been less variation between those lows and highs. So those areas that have that black stippling are showing a statistically significant trend, and anything in yellow or orange is an increase. We've also seen some significant changes in precipitation, and this varies by season. So in Missouri, in the summer, we've seen a significant decrease in the total precipitation, especially in the southwestern corner of the state. But across most of the other seasons, we've seen an increase in precipitation, especially in spring and fall. And a lot of this precipitation has been falling in more heavy rain events, so multiple inches happening within one day. And that's been leading to increases in stream flow and flooding. Our assessment also includes projections of future change. And so the next couple of slides are going to show projections for the end of this century, the last 30 years of this century, under a low emission scenario coupled with a model that is less sensitive to changes in greenhouse gases. So that's giving you kind of the lower end of potential change. And then under a high emission scenario with a more sensitive model. So that's giving you sort of like the business as usual scenario and on the higher end of what we expect for change. So on the top figure are the low emission scenario, and the bottom is the high emission scenario. And this is for the last 30 years of this century, so 2070 to 2099, compared to the last 30 years of the last century. And under both the low and high emission scenario, we expect to see some significant warming. There's no statistical significance shown here because this is a model, but what we see is that under a higher emission scenario, we expect warming of about 8 to 10 degrees Fahrenheit by the end of the century compared to the last 30 years of the 20th century. And under a low emission scenario, warming of a few degrees, maybe up to 4 degrees Fahrenheit. We also expect increases in precipitation primarily in winter and spring. So any of those areas in green are showing an increase. But then we have less certainty about what is going to happen in the summer, where one model is suggesting an increase in precipitation and one is suggesting a decrease. And what we do expect is that we will have more of those heavy rain events with dry periods in between. And because of warmer summer temperatures, we expect more evaporative loss from soil, and so more soil dryness in the summer. And in the fall, we also expect a reduction in total precipitation. So what does this mean for trees and forests? My colleagues at the Forest Service have developed a model to assess habitat suitability for tree species, and this looks at statistical relationships between forest inventory and analysis data and climate, soils, and topography. And you can access all of these model projections on the Forest Service Climate Change Tree Atlas website. So some of the species we expect will have the most dramatic losses include scarlet oak. So the next several slides are going to be arranged in a similar way. So on the left, we have current suitable habitat for scarlet oak, and on the right is projected change for the last 30 years of this century under a low and high emission scenario. So high is on top, low is on the bottom. Areas that are green or blue are showing highly suitable habitat, and those areas that are pale yellow or just slightly yellow are less suitable habitat. And as you can see under both the low and high emission scenario, that little green blip in southeastern Missouri is virtually gone. White oak is also expected to experience a decline in suitable habitat, but because it is so abundant on the landscape, we don't expect it's going to be lost and will still be a dominant species. but we might see more stress or more declines in less suitable sites for white oak. So we still expect suitable habitat, but potentially some declines in productivity and some mortality on marginal sites. Under just the high emissions scenario, we do expect declines for black oak. So again, not dramatic. It's still a pretty dominant species on the landscape. You still see that green under the high emissions scenario, but just a little bit less than you do for current habitat. Black walnut is one where under a low emission scenario, we might see an increase in suitable habitat across northern Missouri, but under a high emission scenario, we expect a pretty dramatic loss in habitat suitability. Some species might not change much. So pin oak is at the center of its range in Missouri, and under both a low and high emission scenario, it's expected to retain suitable habitat. There are some species we expect might gain suitable habitat, either expand from where they are currently or just become more prominent on the landscape. So post oak is one that under both a low and a high emission scenario, we expect will gain suitable habitat in Missouri. Southern red oak, which is not very common now in Missouri, is expected to gain some suitable habitat, especially under that high emission scenario. So you can see that green and that dark yellow moving in. So I'm not saying that you necessarily are going to want to plant it, but you might start seeing that popping up more as you move on. Shortleaf pine is a species that is currently constrained to just certain parts of the Ozarks region, and under both a low and a high emission scenario, we expect habitat suitability to increase for shortleaf pine. So again, this does not mean that we're going to necessarily see species move across the landscape into these places. It just means that according to soil conditions, topography, and climate, those areas might be suitable for those species in the near future. We also looked at the vulnerability of ecosystems as a whole using a combination of models and expert panel processes. So under that work, what we have found is that the highest vulnerability sites for the Central Hardwoods region include mesic upland forests, and these are expected to see reduced habitat suitability for many of their dominant species because of less soil moisture in the summer and the fall. Bottomland forests are also expected to be somewhat vulnerable because of projected changes in precipitation leading to more variable flood regimes, and model projections are mixed for some of the dominant species in these bottomland systems. Now, a lot of what people are interested in the Ozarks are these dry mesic forests or more open woodlands. And here we might see declines for some species and increases for others. And so because there's quite a bit of biodiversity of different oak species and different other hardwood species, and these systems are pretty widespread and connected, we expect that we'll retain these systems on the landscape, but they might change in composition or structure over time. Woodlands, very open woodlands, barrens and savannas are expected to be generally adapted to projected future change. Of course, this really depends on management, as many of these systems are highly fragmented, but they contain a lot of species that are well adapted to warmer temperatures, more disturbance, drought and fire. So it really just is going to depend on our ability to manage these systems into the future. So some implications for the forest industry to consider with this assessment. We do expect declines in habitat suitability for some commercially important oaks in some locations. So white, scarlet, and black oak might see some declines, but scarlet is the one that we're most concerned about as far as the model projections are concerned. Other oak species may thrive in the area. Post oak, again, is expected to gain suitable habitat. There might be other oak species like southern red oak that might be coming in. And there's also a potential for expanding suitability for shortleaf pine. So can we plan ahead and think about how we can develop markets for shortleaf pine, given that it is expected to gain suitable habitat in the area? So I talked about the vulnerability assessment, but I also wanted to just mention some of the work that we're doing on adaptation, about how we're using this information to make decisions. Just briefly, adaptation can be defined as the adjustment of systems in response to climate change. These activities can build on sustainable management, conservation, and restoration work that you're already doing, but it just is done in a more climate-informed way. We've developed a suite of resources that is called Forest Adaptation Resources. It includes a workbook that you can download or order from the Northern Research Station website. You can also find more information on the link below, forestadaptation.org. And we also have an online version of this called the Adaptation Workbook, adaptationworkbook.org, and you can set up an account, and the results from the Central Hardwoods Assessment are already integrated into this online tool, so you can use it for developing your own adaptation projects. Doesn't make recommendations, but rather walks you through a series of questions and steps to develop your own adaptation plan. The adaptation workbook has 5 steps. You start with defining your own goals and objectives, then integrate vulnerability information to assess vulnerabilities on a particular project location. You evaluate your objectives given those changes. And then we provide a menu of potential adaptation options to identify adaptation strategies and prompt you with questions to think about monitoring the effectiveness of your adaptation actions. We have hundreds of demonstrations of these projects on our website, forestadaptation.org, including several in Missouri. We'd love to have more examples in your region. So if anybody is interested in working with us, I'd be happy to talk with you. And I'm just going to talk about one example of a project here in Missouri on Jerktail Mountain in the Ozarks. So this project was a cross-ownership project between the Ozark National Scenic Riverways and the LAD Foundation's Pioneer Forest. Funding was received from the Wildlife Conservation Society Adaptation Fund. This is a competitive grant that's focused specifically on climate change adaptation, and if you're interested, I'd be happy to tell you more about that. So their overall goals were to improve the natural community health and resilience while also providing timber products. They used the adaptation workbook on 2 habitat types in this area. One area of woodland had a large component of scarlet oak, which was projected to do poorly under a changing climate, but it had a high diversity and open structure that helped reduce its vulnerability. There was also glade areas within this project area, and the main issue there was eastern red cedar encroachment. And so because the herbaceous glade species are adapted to future climate conditions, there is a need to restore those glade ecosystems to their previous condition. Some of the climate change challenges included that they may need to shift the timing of prescribed burns to align with seasonal changes in climate, and that wetter conditions during some seasons could also make timber harvesting more difficult. opportunities included climate change may make conditions more favorable to some glade species, and the managers with the LAD Foundation had a lot of flexibility to adjust the timing of harvesting and prescribed fire. Some of the adaptation actions that they selected included restoring fire to fire-adapted ecosystems by employing a variable intensity prescribed fire every 3 to 4 years, and then shifting to 5 years after they had established their site. To prioritize and protect existing populations on unique sites, there was mechanical reduction in eastern red cedar, and to reduce competition. And then one of their approaches was to favor and restore native species that are expected to be better adapted to future conditions. So there they did some selective thinning, focused on removing scarlet oak and other species not favored under future climate conditions to allow those more climate adapted species to thrive. They have been doing monitoring of the herbaceous layer to look at species richness and cover, and initial monitoring results do suggest that their management has been effective at increasing the richness and cover in those glade systems. So to summarize, we, from our vulnerability assessment, have found that climate is already changing in Missouri, and changes are expected to be more rapid in the near future and more intense. We expect a shift in habitat suitability for some commercially important oaks and newly suitable habitat for shortleaf pine. We do have a bunch of resources available to help with adapting to those changes, and our group is available to work with forest managers on projects such as the one that I mentioned in this presentation. So I'm happy to work with you, and I'll leave my contact information, and feel free to get in touch with me after this presentation. So here's my email address, and then our website where we have more information is at forestadaptation.org on the bottom. So with that, I'm happy to answer any questions you may have.
All right, Leslie, we do have a couple of questions for you. Some relate to whether or not climate change is real or not. So what evidence is there to say that this is climate change and not a natural cycle?
Yes, so that is a great question. So we have been working for the last over a decade now in our group on climate change related research. We have contributed to the National Climate Assessment and studies for the Intergovernmental Panel on Climate Change, and the scientific consensus based on the best available science is that that the changes in temperature that we have been experiencing are due to changes in greenhouse gases. Some of that is able to be shown through the modeling that has been done. So basically, if we don't include greenhouse gas forcing in those models, we're not able to replicate the temperature that is changes that are currently occurring in across the globe. There's some other evidence as well. I can point people to a number of other resources, but that's not really the focus of my talk. I think regardless of what the cause is, this is what we're seeing. So regardless of why, we are seeing changes in temperature and precipitation in the area, and so we will need to adapt to those changes regardless of why.
Okay, and I chuckled a little bit when I saw this next question, because I asked you yesterday during our trial run, do you or your organization recommend or have actively looked into assisted migration of some of the winners in the climate change models?
Yeah, so that's a great question. And I would say that this is something we're still at a piloting and experimental phase. There are several things that we're thinking about. So I'm currently working with a team with the Superior National Forest, which is on the southern end of the boreal forest. And so that's an area where they're seeing some dramatic changes, where they're seeing loss in a lot of their dominant species. And so they wanted to develop some guidelines and strategies around what would be prudent for assisted migration. So we're bringing in geneticists and other experts on silviculture to develop a strategy for the Superior, and that's something that's ongoing. We are also doing a project called Adaptive Silviculture for Climate Change, where we're developing trial sites across the country. This is in collaboration with Linda Nagel, who is the department head at Colorado State University and a silviculturist. We have several of these sites in place. We don't currently have one for the Central Hardwoods region, although I know that there's interest. And we've talked with several folks about this, but these projects are replicated operational scale projects where we're employing different adaptation strategies. And one of the strategies is focused on trying to align with future model projections. And there, in a lot of the sites, there has been some experimental assisted migration. So the Cutfoot Experimental Forest in northern Minnesota is currently doing that, and they've been underway for several years, so they're just starting to publish some preliminary results.
And what feature about scarlet oak makes it project to diminish in the future?
That is an excellent question, and I've been trying to figure that out myself. So if you go into the Climate Change Tree Atlas, there is a summary of predictor variables that you can look at, and that will show you what components of the model are driving those changes. And it appears soils are a big part of what is determining habitat suitability for scarlet oak. There are also some specific things about winter and summer temperatures. I am not quite sure. I'm not an expert on scarlet oak, but that is what the models are telling us. Whether that's what we're going to see on the ground or not is where all of you come in, and why it would be really great to develop some more adaptation projects or experiments to really look at these questions and understand what's going on the ground.
Yeah, I know, having worked in the Ozarks for a little bit, it always seems like scarlet oak just struggles in our location, even under good conditions. It just doesn't hold out as well as white oak or red oak or black oak, and tends to die out of the canopy sooner. So I think as we move into drier conditions, I wonder if that's part of it and impacts a little bit harder. But interesting question to explore in greater detail.
Yeah, I mean, it is at the western extent of its range in Missouri, so it could be a soil moisture issue. That didn't come up as a top predictor of its habitat suitability, but that might be part of it.
Okay, and do you have any insight into how the understory impact on forest understory and climate change expectations? You know, the discussion earlier talked about certain species in the understory that are very common these days, and wondering if those would change, I guess.
Are you talking about like seedlings and saplings, or are you talking about herbaceous species?
Yeah, well, the question's a little generic. Maybe they'll comment again, and we'll get clarification there.
Yeah, so I mean, I would say in the regeneration layer, a lot of it's going to depend on light availability for a lot of species that require that to advance. With the herbaceous layer, we don't know a lot about a lot of species and how they're going to react to changes in climate. We expect that a lot of the prairie species that are also present in like the Great Plains are probably going to be pretty well adapted to future conditions. You can look at climate analogs for future conditions. So we expect that Missouri will be more like, places like, Texas and Oklahoma at some point, depending on the season. So there's not a perfect analog, but if you have certain species that do well in those locations, they're probably going to be able to make it in the future. And that's why we're so interested in seeing what happens with those glade species.
Okay, glad you touched on that because they were interested in not just seedlings, but all flora. So that's great. I believe that's all the time we have for questions at this time. There are a few more. I promise you we will get to your questions and get some answers back to you. If I can't answer them, I'll consult with Leslie and get her response to them. And we will get answers to those to you, hopefully before the end of the conference today. If not, we'll post them on the FOAM website and take care of them that way.
All right, I'll stop sharing, and thanks so much for the great questions.